Nerding and Hoarding. Quick and dirty DIY electronics.
Hello and welcome to Nerding and Hoarding. Today we're doing everything backwards. Um, Maybe you heard about the distinction between analog electronics and digital electronics. Analog electronics is about voltages that are in every different level. It can be 2.4, it could be 0.3, it could be 8.5, it could be anything. And it can go in sine waves and everything like that. And then there is a digital that can only go from 1 to 0, to 1 to 0. But actually, often it goes from 5 volts to 0 volts, to 5 volts to 0 volts, to 5 volts. And in the digital, you have these building blocks that look like this, and you can buy them in chips, integrated circuits. But okay, now comes the next part of this video is that you can also build these building blocks using resistors, diodes, and transistors. So that brings us to the next step of this video, which is the discrete AND gate. For example, if I start it here, you see when both these lights are on, this will be on. So not so terribly interesting. You could use it for, if you are making noise circuits, you could use it. But yes, there are more interesting things we can do with it, I tell you. Yes, and here we have the discrete OR gate. It works in the same way. Let me just borrow this so we can easily demonstrate it. You don't say easier, you say more easy, right? Okay, I'm sorry. Sorry, but you see, so either that one or both, and this is on. So it's pretty much on all the time as it seems, at least in this speed here. Yes, now we are more. And then the NOT gate looks like this. Ding, 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 ding. And we also have a little bit more complex here, the X or the exclusively OR gate. And here is where we come to a little bit more of what I am going to do with it. So I thought I like this. Actually, it was a long time ago, but what if you instead of putting in your nice digital inputs here, what if you would put in analog inputs here? What would happen? And that is everything that this video is about. And I will also build something cool that does exactly this. So let's look at this. Look at this. Let's see. Yes, and yes. And stack them up. So look at this here. What is it doing? Well, it's pretty much... No, it's something wrong here. I can tell you that definitely. Yes, we're having the same here. That's the problem. Okay. So sorry about that. Sorry about that. We have to change this frequency here to 55.6, for example. So you see what's actually happening is some kind of modulation. Some kind of modulation is going on. And I cannot exactly say what, but it looks sort of as it's cutting out cutting out from it. Anyway. So let's look at the OR gate. How does the OR gate look when we give it some sine waves here? Let's see. Yes, it looks also different, so that's good. Okay, so I accidentally didn't make a comma there because this application, you see what's happening with the waves here. I'm not exactly sure what it's called, but it looks kind of cool, I would think. Yes. The NOT gate, maybe not so fun, but the exclusive OR gate is quite interesting, I would say. Or I mean, I can't say it. I can think it. I think. So now look at this one, and we remove the other ones. So what is it actually doing? It's doing something really strange, which is amazing. What can happen if I would, for example, lower this voltage down? You know what this looks like? It looks like a fuzz pedal, actually, exactly. So we could actually listen to this if we wanted to. Yes, in a while it would take a little while to render the sound, but yes, we will get a very short sound example right here. Sounds amazing. But do you know what? This is not it. There is more to come, because what if I told you something like this? Wait a minute. Input a variable voltage. So now we have been at 5 volts and so on, and the diodes are only working as one-way streets for electricity. But if we would do like this instead, do you know what happens? Or wait a minute, if I would, yes, so this is the variable voltage. Let's go from here and let's take for example, we take one, doesn't matter which way we do it, but we make a voltage divider like this. And let's look at what's happening with the voltage. Please look at what is happening with the voltages. Let's see. What am I doing? Yes, stack and run. So, okay, so it's very slow here. I have to sort of zoom in or something. I'm not understanding what's happening here. Okay, I'm having a little bit of a problem because I'm stuck on changing this thing right here. Why is that? Yeah, okay. So it's not working at all. So let's do like this instead. Much better. Okay. Please allow me to take this, everything here, and put it into another circuit, because this one seems to be sort of overwhelming this system because I put so much in it, you know. You're not supposed to do that. Okay. So what am I trying to say here? I'm just telling you to look at the oscilloscopes down here, please. And could we please get something here? Yes, okay. So, okay, let's see what's happening. Okay, not too much is actually happening. There's some kind of problem here. Okay. I'm not really sure how I should demonstrate this. Let's do it with a triangle wave, maybe. A triangle wave like this. Okay, and we have to put it in. So it's gonna be like that. Yes, and we take max scale and we take also this in a new scope and we put it as stack them up. So, do you see what's happening? No, I don't even see what's happening. I definitely don't see what's happening here. So, how can this be for real here? Okay. So, do you see what I am seeing? Well, what I am seeing is that it's getting bent, which is very strange. Isn't that strange now? Let me tell you that's strange, but it's not so strange, but you know, it's very interesting. Do you know why? So this is an effect of the diode's way of functioning. So you see, it's not a triangle wave anymore. It's a bent sine wave. So therefore, I will, let's see what I will try to show you here. Okay. So what if we also use this effect here? So let's say we have 0.3 volts here and we have 0.5 volts here. So what is going to happen with this? Okay, I forgot to change it so it's still square, but we want it to be triangle. So something is happening, but I don't know what exactly. And why is this shining? It's not supposed to shine here. And this is not supposed to be like this. There's something wrong here. I'm so sorry, my dear people here. I forgot to change this one. That's why the problem is. So. So do you see what I am seeing right here? Something very strange. And do you know what I call strange? I call it beautiful. Yes, that's what I do. So what if we would just take this now and buffer it and then we remove the bias like this and we would then amplify it and put it in an audio circuit. What do you think about that? How good is that idea? Actually, it's either this or you put a filter on the square waves instead. But this is one idea that I will go with in this project. So we have to amplify it now. So how large is it? So it's a sort of 150 milli. So we sort of have to amplify it 80 times or something like that. Ridiculously a lot. But that's quite simple to do. We just take 80 here and 1 there, and we will probably get it to be correct because it's super easy to calculate with these kind of operational amplifiers. Well, unfortunately not. But wait a minute. We have to wait a minute for it to sink down here. Yes, you see it's now it's sinking because this kind of bias removing network will take some time to. So if we look at this here, we can see how it's actually sinking, and soon it will center around 0. It takes a little while. No, not stack. What did I do? Stack. Unstack. What I wanted to do was max scale like that. So you see it's centering around 0 here, and this one is becoming 9 volts there. So let's even listen to it now, because we can listen to it. But then I'm going to make some little layouts and and then we will try to put some kind of product in the works. So what am I doing? Output, audio output, like that. Yes. All right. So we'll just wait. Well, the reason why it takes so long is because I have so many things in the same document here. You see, I have this, and this. So 5 times. So it is 5 different circuits in one. So when I try to render an audio clip here, it takes 5 times as long as it's supposed to do. So let's just pause here. All right, let's listen to this. Wow. Well, it looks more cooler than it sounds, I guess. But if we look down here, I have done a similar thing. And yeah, it's really going to be so cool, this. This was just an alternative if you want to turn an analog signal into a digital signal. Then you can use this one first to cut it down so it becomes only between 0 and 5 instead of from 12 to minus 12, and this one turns any wave into a square wave of this particular 5 volts positive, 0 point negative. So if you would combine these two, you could take any wave. So I will keep that as an alternative. So maybe we switch this in and we switch this in to any of the inputs. So we can use them both as they are intended to be used with square wave inputs. Because what I want to do is put inputs on a module on one side, and then we have, you can choose, do you want to go through here or through there or through there, and then go out on the other side. So there you go. But I won't do it now because it's too late. But thanks for watching, and see you another time.
Nerding and Hoarding. Quick and dirty DIY electronics.